IKWP, 小攻 aboard, your learning journey starts now. Ever stared at an opponent's move and thought, how did they even think of that? Whether it's a military drill, a diplomatic standoff, or trying to predict some rogue actor's next step, understanding their decision process is critical. But traditional methods often stuck in a rut. Today, we unveil a sleek new approach, fusing structured knowledge with unstructured text. Let's crack this nut wide open. So, how does this magic happen? We've got a dual track system. Think of it like this one. Track is the strict teacher, the teaching track. It feeds on hard data doctrines, organizational charts, strategic goals, building a knowledge graph using the Decay WP framework. This gives us clear, logical rules for prediction. The other track is the insightful mentor, the nurturing track. This dives into the messy world of unstructured text memoirs, historical accounts, cultural narratives, using large language models to extract deep-seated preferences and behavioral tendencies. Now, the real genius is the fusion engine. It takes both outputs, runs them through rule-based checks for consistency, and then uses advanced machine learning, like GNNs and attention mechanisms, to blend them seamlessly. The result? Not just a guess, but a probabilistic forecast of opponent actions, complete with confidence scores and reasoning. Now, here's where it gets really elegant, the DIC-WP semantic mapping. This isn't just a jargon, it's the secret sauce ensuring our two tracks actually talk to each other. Imagine pulling out a general's preference for flanking maneuvers from their memoir. That insight, via DIKWP, gets mapped onto the knowledge layer node in our structured knowledge graph. Similarly, inferring a nation's core value from religious texts maps to the intent layer. This mapping ensures everything aligns semantically. It means the fusion engine isn't just mixing apples and oranges. It's creating a unified understanding. This leads to predictions that are not only more accurate but also explainable, giving us that crucial why behind the what. Okay, theory is great, but does it work in the wild? Absolutely. In military simulations, this method can predict if an opponent will favor a risky flanking maneuver over a standard frontal assault based on both their doctrine and the commander's known style. In diplomatic scenarios, it can forecast when a negotiator will dig their heels in on core issues versus making tactical concessions elsewhere, blending official policy with personal negotiation habits. The output isn't just abstract probabilities. It translates directly into actionable intelligence, specific strategic intent paths, and tailored counter strategies. Compared to relying solely on human experts, this system crunches vast amounts of diverse information much faster, delivering high-quality insights right when you need them. So, why is this better than what came before? Simple. It combines the best of both worlds. You get the stability and interpretability of rule-based systems from the teaching track, plus the flexibility and nuance of data-driven models from the nurturing track. When these two disagree, the fusion engine has smart conflict resolution mechanisms, adjusting weights or flagging inconsistencies. Crucially, the DIKWP framework ensures the whole thing remains grounded and explainable. The payoff: a significantly more accurate, robust, and trustworthy way to model complex opponent decisions, ready for the toughest challenges. That's the power of fusion,